This is Chapter 4, Goal 16, and you should not be completing this screencast until you have watched the Goal 16 notes. So this is for the examples only, so if you have not yet watched Goal 16 notes, please go back and watch that screencast. But so let's go through some examples of graphing cosecant and secant. When you sketch this function, make sure that you find the amplitude, the period, any phase shift, any vertical shifts, and then as usual we're going to make sure we label along the x-axis endpoints and midpoints, and then the max and the min on the y-axis. Number 1 is asking you to graph y equals the cosecant of x divided by 2. As you learned in the previous video, to sketch cosecant, it's easiest if you first sketch its reciprocal function, and we know that the reciprocal of cosecant is sine. So if we find our amplitude, we know the amplitude is the absolute value of the coefficient of the trig function. In this case, our amplitude is 1. Our period, to calculate the period, we take 2 pi and divide by b. Remember, b is the coefficient of x, so in this case that's 1/2. And so our period is 4 pi. There is no phase shift. We are not adding or subtracting any values to x. There is no vertical shift. We are not adding or subtracting any values to the function. So let's sketch sine of x divided by 2. I'd like you to pause the screencast, plot 1 period of sine half x, and then turn it back on, and we'll discuss using that to sketch cosecant. Okay, so you can see that our function has an amplitude of 1, our max of 1 and min of -1, and our period is 4 pi radians long. So to use sine in order to sketch cosecant, we recall the relationship between sine and cosecant. They are inverse functions. So everywhere that sine equals 0, cosecant will be equal to the reciprocal of 0. And the reciprocal of 0, if you're not sure, I know we've discussed this a lot, but we can take 0 and put it over 1. And now if we flip that or write the reciprocal is 1 divided by 0, which we know is undefined. And to show that our function is undefined, we would place vertical asymptotes everywhere that the sine function is equal to 0. The max point is 1, so where sine equals 1, cosecant will equal the reciprocal of that. The reciprocal of 1 is 1. And if we reciprocate our other points where sine opens down, cosecant will open up, and where sine opens up, cosecant will open down. Remember, as you learned in the previous screencast, that the maximum of sine is the minimum, relative minimum of cosecant, and the relative minimum of sine is the relative max of cosecant. All right, let's look at number 2. Example number 2, y equals 2 secant 2x. So we know that secant is the reciprocal of cosine, so we will first sketch cosine 2 cosine 2x and use that to sketch secant. Please pause the screencast, find your amplitude, period, phase shifts, vertical shifts, sketch the cosine, and then turn it back on to check your work. Okay, so the amplitude of cosine is 2. So there's my max and min at 2 and -2. The period is, the value for b is 2, and 2 pi divided by 2 is pi, so the period length is pi. So with using cosine to sketch secant, remember that wherever cosine equals 0, secant, its reciprocal, will be undefined. Wherever cosine opens down, secant will open up, and wherever cosine opens up, secant will open down, remembering not to pass through those vertical asymptotes. Please pause the screencast and try number 3. Remember, first sketch since this function is cosine, sketch the sine, check it, and then we'll talk about cosecant. Okay, so A is 3, so the amplitude is 3. B is also 3, so the period is 2 pi divided by 3. And because I am subtracting pi, I know that there's going to be a phase shift or a horizontal shift because pi is in parentheses with x. So I set 3x minus pi inside an inequality with the domain of the parent function. And when we finally isolate x, we find that the phase shift is pi over 3 radians to the right, and the function will begin at pi over 3 and end at pi. And remember, the distance between the starting point and the ending point should be equivalent to your period length. And if it's not, that just tells you you've made an error somewhere to go back and check your work. So I've sketched the function showing the phase shift, and then our maximum of 3 and our minimum of -3. So remember, everywhere that sine equals 0, cosecant will be undefined, and we will show that with vertical asymptotes. Where sine opens down, cosecant will open up, and where sine opens up, cosecant, the reciprocal function, will open down. Finally, on number 4, it's asking us to sketch secant. So please pause the screencast and find the information for its reciprocal function, y equals negative cosine of pi over 4x minus pi over 2. So find that information, sketch the cosine, and then turn back on to check. Okay, the coefficient of cosine is -1, so the amplitude is 1. That gives us our max of 1 and min of -1. Notice that because the coefficient of cosine was negative, I started at -2 when I graphed the function. I started at -1 when I graphed the function. Coefficient of x, or b, is pi over 4, so that gives us a period of 8. So notice that the distance between my two endpoints is 8 units. 10 minus 2 is 8. Then I took bx minus c, or the value in parentheses, and because I know that's a horizontal shift or a phase shift, I placed that between 0 and 2 pi, the domain of our parent function, and solved for x. So this takes into account changing the period length and shifting. So our phase shift is 2 units to the right, or 2 radians to the right. And so now let's sketch secant right on top of this. Everywhere that cosine equals 0, secant will be undefined. Where cosine opens up, secant will open down. And where cosine opens down, secant will open up. That concludes our examples for the reciprocal functions secant and cosecant. Thank you.